Hello, my little mathematicians. Today, we're going to explore how to solve ratios using what's called cross products. You'll also heard it referred to as cross multiplying or the X method, the butterfly method, or sometimes even the heart or love method. Okay, they're all saying the same thing. So first off, just a reminder, remember that a ratio is a comparison between two quantities or measurements. Okay, and what we're going to be exploring is we're going to be setting two ratios equal to each other to see if they're equivalent ratios. And equivalent ratios are, again, two ratios that are set. Let's fill that in with equal. When they're fully simplified or reduced. And one way that we can check that, because if it's a really big number and it's a pain in the butt to reduce, is you can check their cross products. So I'm going to skip this section really fast and I'm going to go down to here to show you what a cross product is. Okay. So that's the numbers that are directly across from each other. So you would multiply this B times C and you'd set that equal to these two numbers that are across from each other, the A times the D. Okay, it'll make more sense once we start doing some. Okay, so again, this times this is equal to this times this, and like let's test it with this right here. Are these equal to each other? Well, if I reduce this, what does this reduce to? It reduces by 2, right? What's 4 divided by 2? 2. What's 10 divided by 2? 5. Okay, what can this reduce by? 3's, right? What's 6 divided by 3? 2. And what's 15 divided by 3? 5. So do you see that both 6/15 and 4/10 reduces to 2/5, right? So we know that these two ratios or fractions are equivalent to each other. And rather than having to reduce them, I could have checked their cross products, which is this one times this one. So the 4 times 15, which, what is 4 times 15? 60. And set that equal to these two numbers across from each other, 6 times 10. What's 6 times 10? You guessed it, 60. So is 60 equal to 60? Yes, it is. So if the two cross products are equal to each other, then you know that those two fractions or ratios are equivalent and equal to each other. So up here, again, you could test these. Okay, that's fully reduced. This one I could reduce by 5 and I get 1/2. Hey, look, 1/2 is equal to 1/2. But instead of doing that, I could have done cross products. Is 1 times 10 equal to that 2 times 5? Well, 1 times 10 is 10, and 2 times 5 is also 10. Okay, so then let's try the cross products again. Okay, 4 times 9 is equal to, 3 times 12. And what does this one equal on the left? 36. And what does the right side equal? Also 36. So then you can say, yes, these are equivalent to each other. So you would put yes for this one, yes for this one. And then this one, when I multiply, what's 5 times 5? 25. And set that equal to this times this. Well, what's 4 times 6? 24. So is the right equal to the left? Sure isn't. So then those two aren't equivalent ratios. When this reduces, it's not going to be equal to this, which you can kind of already tell because isn't this fully reduced? And isn't this fully reduced? And they're not equal to each other. So, duh, those aren't going to be equal. And you're like, okay, well, then I just always want to fully reduce them. Sure. But then what if you had these huge, massive numbers like this one? I don't want to try to reduce this fraction and reduce this fraction and see if they reduce to the same thing. So instead, what I would want to do is do the cross products. So I would set this times this, which if I do 39 times 272 and set that equal to the other side, which is 48 times 221, I want to see if those end up being equal to each other. So go ahead and type those into your calculator. 39 times 272, and you get 10,608. Let's see if this is equal to this side. Well, that side is 48 times 221. And you get 10,608. Were those equal? They sure were. And I didn't have to reduce those horrid fractions. So that's why we like cross products. It's also good, not only just for determining if they're equal or equivalent to each other, but if you have to solve for a missing piece. Like, for instance, this right here. Okay, I could do 2 times 20 and set that equal to 5 times x. Okay, well, what is 2 times 20? It's 40. And then bring down the equals 5x. And now you're like, okay, what this is saying is that 5 times something is going to be equal to 40. Okay, because we know that this cross product has to be equal to this cross product in order for these two ratios to be equivalent, as we just proved up here. So then how do I figure out 5 times what is 40? Well, these are being multiplied. And what's the inverse of multiplying? Dividing. So I do that so that the 5 divided by 5 cancels to become 1, and now you have 1x, or just x. I can do that as long as I do the same thing to the other side. What's 40 divided by 5? Yep, 8. Now remember, you can always speed up the video, slow it down. You can also pause it, try one yourself, and then unpause it and come back and join us. Which, by the way, why don't you do that for this one? Okay, now that you're back with us, you're going to do 40 times 6 and set that equal to 24x. Okay, what is 40 times 6? Well, 4 times 6 is 24, and then tack on a 0. And then to get x by itself, I'm going to divide by 24 so that this cancels and becomes 1, or 1x. And then 240 divided by 24 is 10. Okay, last one here. If you haven't tried any yourself, please try this one on your own. Okay, now that you're back with us, you have 4x equals this times this, which is 6 times 22. So when you plug in 6 times 22, you get 132. And now to get x by itself, I need to get rid of that 4, which is being multiplied, and the inverse of multiplying is to divide, so that I can do 4 divided by 4 is 1, or 1x. And don't forget, do it to the other side as well. And 132 divided by 4, you get 33. Okay, and there you go. You just solved for the missing piece in order to create an equivalent ratio by using cross products. Now, there is another way that we could do these same problems. If you notice, these are the same as these. We used to just call it the shortcut method. You can say like the here to there, whatever. Okay, sometimes this method works. Okay, so you're going to see, you're like, oh my gosh, why didn't you show me this? It's so much easier. Well, because this way over here on the left always works. This one only sometimes works, but when it does work, so much nicer. You ready for it? Okay, first off, always move towards the direction of your unknown. So draw an arrow here, and I'm going to do that same thing here. And then ask yourself, 5 times what is 20? Yeah, 4. So then do the same thing here of 2 times 4, and you get 8. The missing one was 8, just like we solved for over there. You're like, oh my gosh, it was so much easier. Yes, but remember, this only sometimes works. Okay, does it work for this one? Go towards your unknown. Can you go from 24 to 6? You sure can, if you what? Yep, divide by 4. So then do the same thing here and do 40 divided by 4, and what do you get? 10. Perfect, and that's what we got over there, so we know we're right. Okay, and the only trick is like make sure you actually go towards the direction of your unknown. So I want to go this way. How do you get from 4 to 6? You're like, well, I can't just do that in my head. Okay, we'll do 6 divided by 4. Does it go in nicely? Yeah, if it's basically just multiplying by 1.5. So then multiply this 22 by 1.5. And what did you get? 33, which is the same thing we got here. So we know we're right. Okay. Now you're like, I always want to do it this way. Remember, it only sometimes works. So let's go ahead and try these on the back. Okay. And now I'm not telling you which method to use. You get to choose. So I always want to try to see if I can do that easier method first. Okay. So move towards your unknown, which is this way. Can you go from 4 to 8? Yeah. If you just multiply by 2. So then 3 times 2 is going to give me 6. Okay, now that we've tried enough of these, I really want you to try to pause the video and try all the ones on this back page, and then check yourself, and then just fast forward to the ones that you need help on, okay? So try them all yourself. All right, you're back with us. Let's try the shortcut on this guy. So if I go ahead and I go towards my unknown, can you go from 21 to 7? Yeah, if you divide by 3. So then divide this one by 3, and 36 divided by 3 is 12. Now you see why it's really important for me to always say, go towards your unknown, because a lot of you probably did multiplying by 3, because you're like, 7 times 3 is 21. But you always want to go towards the unknown, which is going this way, from the 21 to the 7, not the 7 to the 21. Okay, so I know it seems lame, but please do those arrows. You'll save yourself a lot of tears later on from making silly mistakes. Okay, go this way, which is going this way. How do you go from 56 to 8? Yep, by dividing by 7. So then go ahead and divide this one by 7, and 42 divided by 7 is 6. All right, I'm going to go ahead and go this way. And so I'm going to go this way as well. And can you go from 4 to 10? Sadly, I can't. Okay, so then let's fall back and do the cross products way. So here, this is across from the 6, so 10 times 6, and set that equal to this one, which is 4 is across from the x. Well, 10 times 6 is 60, and over here we have equals 4x. So how do I get x by itself? Yeah, I need to get rid of that 4, which is being multiplied, so let's go ahead and divide by 4 on both sides. Now those cancel and become 1, or 1x, and over here, when you do 60 divided by 4, you get 15. Okay? This next one, if you went towards the unknown, you're going from 12 to 15. Can you do 12 times something to get 15? Sadly, not really. So let's do our cross products. Here's 8 times 15, and you're going to set that equal to the 12 times the x. We'll type in, what is 8 times 15? 120. And then how do you get x by itself? Yeah, divide by 12. So then these cancel and become 1x. And over here, 120 divided by 12 is 10. How are you doing so far? Doing pretty well? Good. Okay, 3 more left. Go toward your unknown, which is this way. Can you go from 9 to 21? No, they just really don't want me to do this. They really want me to try the cross products, huh? So I'm going to do 9 times x and set that equal to this times this, which is 27 times 21. Well, if I type in 27 times 21, I get 567. And I'm going to set that equal to 9x. Now, how do you get the x by itself? Yep, divide both sides by 9. So those cancel, and you get x was 567 divided by 9? 63. 2 more, almost done. 15 times nothing is 40. Okay, so let's do cross products. 40 is across from x, and we're going to set that equal to the 15 times 16. Well, 15 times 16, when I type that in, I get 240. And I'm going to set that equal to 40x. So now to get x by itself, divide both sides by 40. Those cancel, and you get x those cancel, and 24 divided by 4 is 6. Yeah, did you guys know that cool zero hack? From top to bottom, you're essentially just dividing them both by 10, so then the zeros can cancel out. And then you're just left with 24 over 4, which is 6. Pretty cool trick, huh? Okay, last one. You can't go from 14 to 18, so cross products again. 18 is across from x, so 18x equals 14 times 63. Now, I should have said this earlier, but if you're putting like 14 times 63 over here and the 18x over here, don't be freaking out. It's the same thing. As long as you're multiplying like the same things I am on either side, it doesn't matter if like this whole side was on this side and this whole side was on the left. Okay, you'll still end up getting the same answer. Sorry, I should have said that earlier. Okay, 14 times 63 is, yes, 882. Now, what do you do to get x by itself? Divide by 18. Those cancel, and you get 1x equals, well, 882 divided by 18. Yep, you got 49. How'd you do, little mathematicians? Pretty good? Awesome. You got this. You're going to do amazing. If you missed any, Go back and try some similar problems on the other worksheets, okay?